Good day everyone. Good day sir. I am Kent Alimpag and today I am discussing the assignment number 1 in ME323 refrigeration. Number 1. Carnot refrigeration cycle absorbs heat at negative 12 degrees Celsius and rejects it at 40 degrees Celsius. B. If the cycle is absorbing 15 kilowatts at the negative 12 degrees Celsius temperature, how much power is required? C. If a heat engine between the same temperatures as the above refrigeration cycle, what is the coefficient of performance? If a Carnot's heat pump operates between the same temperatures as the above refrigeration cycle, what is the performance factor? E. What is the rate of the rejection at the 40 degrees Celsius temperature if the heat pump absorbs 15 kilowatts at the negative 12 degrees Celsius temperature? So A, not a given. T1 equals negative 12 degrees Celsius. So, imo ang siyag absolute value plus ang siyag 273 equals to 261 Kelvin. Then the T2 plus ang siyag 273, 40 plus degrees Celsius, 40 degrees Celsius plus 273 is equals 313 Kelvin. Then, ang required is the coefficient of performance refrigeration mana siya? Solution. Ang formula sa COPR is equals to heat absorbed over work equals or T1 over T2 minus T1. Then substitute 261 over 313 minus 261 isolve. Then ang answer, COPR equals 5.019230769. So letter B. Not given na ang iya heat absorb is the 15 kilowatts nya required work na solution. Ang formula is sa COPR equals Q heat absorbed over work. Substitute since ang COPR kay na naman siya value, i-substitute na lang 5.019230769 equals 15 kilowatts over work. I-solve ang answer, work equals 2.988505747 kilowatts. So C. Required is the COPE or the coefficient of performance of the heat engine. Formula niya is the T2 minus T1 over T2 or WE over QR. Then substitute 313 minus 261 over 313. Then solve. COPE equals 0.166. And letter D, here required is the COPP. The solution, COPP equals QR over WP equals T2 over T2 minus T1. Then substitute 316 over 316 minus 261. Resolve. My answer is the COPP equals 6.019230769. So, sa E, given is the heat absorbed is 15 kilowatts, and the T2, 313 Kelvin, T1, 261 Kelvin. Ang iya required is the QR. Solution. QA equals T1. Yeah. Makubalo na term, sir. Yeah, substitute 15 kilowatts equals 261 Kelvin times kana siya. Yeah, solve. The answer is 0.05747126437 kilowatts per Kelvin. So to solve the QR equals T2, then kana, yeah, QR is substitute, T2 is 313 Kelvin, then kana siya na naman siya value, i-substitute na sad 0.05747126437 kilowatts per Kelvin. Then i-solve times, the answer is QR equals 17.9885075 kilowatts. So, number 2. A refrigeration storage is supplied with 10,000 kg of fish at a temperature of 20 degrees Celsius. The fish has to be cooled to negative 10 degrees Celsius for preserving it for a long period without deterioration. The cooling takes place in 10 hours. The specific heat of fish is 0.7 above freezing point and 0.3 below freezing point, which is negative 3 degrees Celsius. The latent heat, which is negative 3 degrees Celsius. The latent heat of the freezing is 55.5 kcal per kilogram. Find the refrigerating capacity of the plant in tons. Given mass equals 10,000 kg, T1 equals 20 degrees Celsius, to become absolute, plus 274 equals 293 Kelvin. Then T2, negative 10 degrees Celsius, plus 273 equals 263 Kelvin. Then the time equals 10 hours. C1 equals 0.7 kcal per kilogram Kelvin. And the C2 equals 0.3 kcal per kilogram Kelvin. And the latent heat is equals to 55.5 kcal per kilogram. Then the TF equals negative 3 degrees Celsius. Add the 273 to become absolute equals 270 Kelvin. And then ang required is refrigeration capacity. The solution. Q1 equals MC1 times T1 minus TF. Then substitute the mass equals 10,000 kg times the C1 0.7 kcal per kilogram Kelvin. Then i-convert siya into kilojoules times 4.187 times 10 raised to the power of negative 3 kilojoules over 1 times 10 to the power of 3 kcal times 293 Kelvin minus 270 Kelvin. Then solve. Minus, cancel ang like terms. Bilhin na lang kilojoules. So, pag solve, the answer is Q1 equals 674107 kilojoules. So, sa Q2 equals MLP. Substitute 10,000 kg times 55.5 kcal per kilogram times i-convert na sa into kilojoules times na siya 4.1 87 times 10 raised to the power of 3 kilojoules over 1 times 10 raised to the power of 3 kcal. Then ang answer niya, cancel ang like terms. The answer is Q2 equals 2323,785 kilojoules. So the Q3 equals MC2 TF times TF minus T2. Substitute 10,000 kilogram times 0.3 kcal per kilogram Kelvin. Ikuha na siya, i-convert. Times 4.187 times 10 raised to the power of 3 kilojoules over 1 times 10 raised to the power of 3 kcal times 270 Kelvin minus 263 Kelvin. Cancel ang like terms sa mabiling kilojoules. Ang pag-solve is, ang answer is Q3 equals 87927 kilojoules. To solve the Q, formula is Q equals Q1 plus Q2 plus Q3. Then, substitute ang each value nila is Q1 is equals to 674107 kilojoule plus Q2 2323785 kilojoules plus the Q3 87927 kilojoules. The answer is the Q equals 3085819 kilojoules. And to solve refrigerating capacity, the formula is Q equals Q over T. Substitute 3085819 kilojoules over 10 hours times 60 minutes over 1 hour. Q equals 5143.031667 kilojoules per minute times 1 ton over 24 kilojoules per minute. Yung answer, Q equals 24.3746 ton. So number 3, if 6,895 kilogram of Imperator carrots enter a chilling cooler at 33.3 degrees Celsius and are chilled to 0 degrees Celsius each day. Determine the product load given. Mass equals 6,895 kilogram. T1 equals 33.3 degrees Celsius since it needs to be absolute. Plus ang 273 equals 306.3 Kelvin. Then T2 equals 0 degrees Celsius plus 273 equals 273 Kelvin. Time niya, since each day, a day is 24 hours. TF equals negative 1.4 degrees Celsius. Kaya siya sir, nani siya sa table. C1 equals 3.92 kilojoules per kilogram Kelvin. C2 equals 2.00 kilojoules per kilogram Kelvin. Then the latent heat equals 293 kilojoules per kilogram. Note, T2 is greater than TF. So, it did not involve freezing. Q1 equals MC1 times T1 minus T2. Then substitute M equals the mass has 6,845 kilogram. Then the C1 3.92 kilojoules per kilogram Kelvin times 306.3 minus 273 Kelvin. Cancel ang like terms niya. I-solve. The answer is Q1 equals 900,045.72 kilojoules. So number 4. For the 6,895 kilogram of Imperator carrots undergoing the cooling the undergoing the cooling described in example 1-3, what would be the refrigeration requirement for this carrot upon reaching 0 degrees Celsius due to only their heat of respiration? Given ang mass niya is 6,895 kg, T1 33.3 degrees Celsius plus ang 273 equals 306.3 Kelvin. At ito is 0 degrees Celsius plus 273 equals 273 Kelvin. Time niya is 24 hours. From the table, heat of respiration at 0 degrees Celsius equals 45.6 mW over kilogram. You solve Q equals 6,895 kg times 45.6 mW per kilogram. You substitute 314,412 mW times 1 watts over 1,000 mass times 1 kilowatts over 1,000 watts. Cancel the like terms. Solve. The answer is Q equals 0.314 kilowatts of refrigeration.